Thank you. Yeah, so as Timothy mentioned, I'm doing this alone, so change of plans. But yeah, so first a bit about me. So I'm a data scientist, data engineer, data architect, working at a company called Just AI. Before that, I was working actually in life science, so I have like 10 years of work in life science, then 5 years in consulting, but all that time working actually with data and with AI. So yeah, doing AI before it was cool. I'm also like a big open source and Linux enthusiast, so working with that for more than 20 years. And what's important for this talk, right, is that going into this project, I had some experience with Kubernetes, but really just from convenience of cloud. So setting this on-prem was actually, a new experience. So just quickly, what will this talk be about? So I'll give you a quick overview of the use case, then our approach to building an MLOps platform without the convenience of the cloud. Then I'll give a quick run through major components we used and why, and so on. We'll touch automation, persistent storage, networking, then logging, and in the end, some minor tips and tricks and useful tools. So this talk won't be about any Kubeflow details, running pipelines on ML jobs. Unfortunately, I also don't have time to talk about details of the International Space Station, nor the algorithms we are actually running on this platform. But let's step back. So how this started? So this work started as part of this project called KISS, and we're developing AI for International Space Station. And by AI, we mean anomaly detection, so different algorithms to detect anomalies. Then once those are detected, we do diagnostics. So we try to find root causes to those anomalies. And then in the end, we also have algorithms and models that suggest what you have to do to mitigate those anomalies. And yeah, so this work is part of a bigger consortium, so 2 universities here in Germany, Airbus, and us, so Just AI. And we, so Just AI, are here focused on the Kubernetes MLOps part. Quickly, nonetheless, about ISS, Columbus. So the data that we are working with comes from ISS Columbus. And this is a module of International Space Station, and it's basically, so it's Europe's first permanent outpost in the orbit. So the module itself is 10 tons, so weighs 10 tons, can take 9 tons of payload, and is 7 meters long. And in contrast, so the whole International Space Station is 450 tons. So it's a part of this larger unit. How it looks inside, so it's a laboratory. It has racks for experiments and infrastructure, but also all over the place there are different sensors that are measuring different parameters, CO2, temperature, whatnot. So there's like over 1,000. So there are like thousands of parameters recorded constantly with like 1 Hz sampling. This results in 30 gigs of data per year compressed, or 600 gigs uncompressed. And this data is very important for the operation of the module itself. So currently, it's monitored manually by people in the ground control center, and we are trying to automate this. And all this is obviously, so it's very important because this is in space, it's different environment. Some stuff that we take here for granted, it's not so in space. Like, for example, due to microgravity, you can have like local pockets of CO2. Right, so you have to constantly monitor, your life support systems. Otherwise, astronauts would be in trouble. Right. So this is about the data, and being sensitive data. We know when the astronauts are in the module and whatnot. So the data is not allowed to go on the public cloud. So this was the major project requirement. But this MLOps platform that we developed for the project must run on all the project partner sites, which means some have like bare metal clusters, some have like corporate data center. We also use the cloud for development, because it's just faster iteration. And when it comes to like the size of the cluster, so I would say that like small to medium clusters, so let's say below 10 nodes. Also, we are only allowed to use open source components, and the users of the platform are end users are data scientists and aerospace engineers, so not necessarily only for software engineers. Right. Anyway, so this was quite a learning curve going to live on premise. So we definitely lost quite a lot of comfort, something that you take for granted when you're deploying on clouds. So suddenly we had to install, configure, like everything, the nodes, the Kubernetes. We had to take care of storage, which was a big one, IAM, load balancers, TLS, monitoring, and whatnot. So it was quite a learning curve. But like starting all this, right? So we first collected, we had a workshop. We collected the requirements that this platform has to fulfill, and then we tried to find, which tools would, address those. So yeah, very early on, we decided to go for Kubernetes, right, to orchestrate all those different workloads. Then for our source code and then registry and CI/CD, we actually went for GitLab because it's one tool but ticks quite a lot of boxes. And yeah, then we digged further. We quickly narrowed down that we're going to use Kubeflow as our data science workbench and also to run ML pipelines. And then from there on, a lot of decisions were actually also quite pragmatic, right? So we either went for something that was or seemed like an already a standard, like Prometheus for monitoring, or if a tool was already somewhat integrated with Kubeflow, or there was a clear path to do it, we then took that and went with it. Right. So let's have a closer look. So there are like, let's say, 3 key components of this platform. So one is GitLab, as mentioned. So we are using it for our source control, CI/CD, and the registry, and also it's open source, so it also ticks that box. Then we had to select the Kubernetes distribution, and actually, so we went for microK8s because it's easy to deploy. It works on most Linux distributions. It supports multi-node, right? So you can deploy it on a single node, but also multi-node. So this is also like a requirement to kind of have like the same experience regardless of the environment. And it is CNCF certified. And what also, kind of draw us to microK8s that initially, so it comes with quite a lot of packages you can easily install. So at least for the initial experimentation, we also started with those, right? So also made our lives a bit easier and learning curve a bit, not that steep. And finally, Kubeflow, right? So this is kind of the central pillar of the platform. It is like a complete data science workbench. So it comes with notebooks, pipelines, with KServe, you can serve your models and whatnot. It's Kubernetes native. It's very mature and stable, and it is also actively deployed. Right. So early on, we realized that we'll have to automate things. So, and this is, heroism is not sustainable. This is actually in Kubernetes values, right? So if possible, you should try to automate as much as possible, especially us. We are a small team, but we have to deploy in different heterogeneous environments. So very early on, we said, okay, let's automate everything. Otherwise, yeah, that's not gonna be sustainable. Yeah, so how we do this? So the deployment is really completely automated. So we can hit bare metal clusters, corporate data centers, or clouds, more or less with a single command. Yeah, and all this gives us quick iterations. It's reproducible and also scales, right? So you don't have to add engineers for any new deployment. Components we're using for that. For infrastructure as code part, we actually decided to go with Ansible. Yes, we quite like it, right? So you define your stuff in YAMLs. It's implemented in Python, supports templating, and what's also quite important for us, is agentless. So you don't need to run any agent on your nodes. You just need SSH access to this. So it's very easy actually to get started and use it. Yeah, so the next component of automation is GitLab CI/CD. Right? You can, again, you work with YAMLs. It's very flexible. You can build packages, you can build containers, and you can connect your Kubernetes clusters and deploy stuff there. And then the final one, it's actually customized. So that's how we deploy stuff on Kubernetes. And yeah, let's have a closer look at that, right? So as you might know, but this was kind of new for some of us, is that deploying stuff on Kubernetes, you more or less have two options, right? Either Helm or customize. And there are also like lengthy discussions online about the benefits and downsides of either of those two tools. So check them out. Some of them are heated, but basically Helm, it's imperative. It supports templating. It actually packages stuff in packages, but it also adds abstraction and is not natively supported. Customize, on the other hand, is declarative. It's built into kube control, works on plain YAMLs, and it's really minimal. And the way how you modify stuff there, it's with overlays and patches. So in the end, after some experimentation, we actually decided to just go with customize, because also very soon we realized that some of the stuff, that we would kind of have to prepare our own Helm charts because we needed more customization than what was available out of the box for some Helm packages. Right. So and this is how we organize our code. So basically, all the manifests for the whole platform are in a single repo, right? And in this repo, so we either pull manifests, official manifests from upstream, if they're available, or we render Helm chart if that's how that piece of software is packaged. So we just do Helm template, and output goes into this repo. Then to adjust this to our use case, we're using custom overlays, right, with customize as mentioned, and then in the end we deploy everything to the clusters with GitLab CI/CD, right? Very simple, kube control, apply -k. So we're in the process of moving to Argo CD, but yeah, not there yet. Yeah, we're also relying on operators quite a lot. It's a lot of software, especially databases, come with operators. So if possible, we use them. Right, and we also wrote a custom operator to handle dynamic changes. So for example, with Kubeflow, if you create a new user, the user gets a namespace, but without any resource quotas on that namespace. So we had some unpleasant experience with that. As the user submitted, I don't know, thousands of jobs at the same time. So didn't end well. Anyway, to enforce those quotas, we wrote our own operator, monitors. If the user comes up, we apply those quotas, and then everyone is safe. Right, so next big one was actually storage, right? Because the cloud storage is just there, you don't need to think about it, but actually bare metal, that's something that's tricky and you really have to think about. And one thing that also didn't have, at least initially, Kubernetes was not really developed for stateful workloads. Nowadays, obviously, that does work, but yeah, that's not how it started. It also, yeah, some documentation might be because of that a bit old, and also stuff changed quite fast in the recent years. So it's tricky to navigate. And also first, we also had to understand how the storage works. But I guess first two layers are familiar anyway, right? Even if you're on the cloud, right? So you have a persistent volume claim, which is something that pod makes. It's namespaced. Then the actual data is in persistent volume, which is a cluster resource, which is created either manually or dynamically. And then in the end, right, so all that is actually provided by some sort of storage engine, which is kind of exposed as a storage class. And this last part is something that, again, being on-prem, we had to figure out how to implement and run reliably. Yeah. And still speaking about storage, so we did some thinking and digging, and in the end we decided, okay, that we're just gonna go with OpenEBS ecosystem to provide our block storage, and we're using OpenEBS host paths, so that's just for the storage on the one node, or if it's like a single node cluster. But if you have like high availability deployments, so multi-node clusters, we're actually using Maya Store as our storage engine. It provides replication. It needs minimum 3 nodes, obviously. But it also has, let's say, fairly strict hardware performance requirements, right? So you check before you're using it. You check, if your network is up to it, if your hard drives are fast enough. But if all those, if all that is fine, right? So it actually works quite nice and reliably. And on your nodes where MyStore is deployed, it needs, it's gonna take over like whole block device, but you can also make it work with sparse files. So and this is how our storage classes look like in our deployment. So we have basically 2 based on MyStores with different replication levels, and 1 that's host path. Okay, the next one was actually also taking care of S3 type of storage, so object storage, because this is something that Kubeflow needs. Actually, Kubeflow comes with MinIO, right, which is an S3 type of storage out of the box, but that version is actually quite old, right, because MinIO changed the license in between. But yeah, we are fine with AGPL license anyway, so we updated MinIO, so we integrated like the latest version of MinIO with Kubeflow. And yeah, so MinIO then taps into your storage class, so in our case, either MyStore or OpenEBS host path, but it can also do like replication itself. So yeah, it's a fine storage. Also works with all the S3 compatible libraries, so you just point it to your endpoint, and yeah, you can use it. Right, and one additional benefit is also has a nice front end. Okay, so that was storage. One big one that we also had to tackle was actually all the networking, right? And here, like, decision was quite pragmatic. So Kubeflow actually ships with Istio. So we just decided to also go with Istio and all the additional services that we are providing. So MinIO, Grafana, Kafka UI, other stuff. We also just expose through Istio, and routing is determined based on prefix. Right, so and this is like internal communication, but then we still had to figure out, okay, so how will the users get in, right? Obviously, in cloud environments, you have load balancers, and your cloud provider takes care of all those things for you. But yeah, bare metal, it's a different story. We're thinking about load balancers, so there's like thing called Metal LB, which is very powerful, but also seemed a bit of an overkill for us, especially for the amount of users. So in the end, we did a pragmatic thing. So we just expose Istio gateway as a node port, and then on the other end, so on the host machines, there's an Nginx server working as a reverse proxy, listening for all the traffic coming from users, and if traffic comes, just sends it over to Istio. So Nginx just sends over the traffic and does TLS termination in our case. Right, so that's networking, and multi-node setups, more or less the same. We just also have a DNS, and we're using like DNS failover, so if like one node is suddenly not available, the user won't notice, right? So DNS will just redirect it to another node. So we can also handle, node outages gracefully without problems. Okay, so speaking about networking, TLS comes to mind, and this is, it is very important, right? And it's really important to get it right. And initially, especially when you embark on such a big project, you kind of start also thinking about shortcuts and so on, right? So you might be tempted, okay, I'm just gonna disable TLS for now, come to it later, right? So yeah, don't do it, right? So it's not worth it because you'll likely just dig some holes in which you'll then fall into. Yeah, so TLS, it's very important. Don't disable it. Rather, right, take your time, familiarize yourself with TLS, how it works, the terminology, what are the keys, certificates, certificate authority, how all that works, chain of trust, and so on. Because yeah, it's important and it has to work properly, right, for like obvious security reasons. And yeah, so deploying your own stuff, obviously you might have different options of how you want to sign your certificates. So you might want to self-sign them. That's one option, but then you have to know, what to do with those certificates and where to insert. So, but there are also like fine public options where you can get certificates for free. Okay, so that was TLS. Next part was then figuring out what to do with users and whole IAM thing, right? Kubeflow comes with DEX, it's fine, right? Works. But on the other hand, so we want to have more things integrated, and that's where often Keycloak comes up. And yeah, initially, so we had some problems, right? So because Keycloak would work with other services, but we couldn't rip out DEX of Kubeflow. But yeah, so in the end, we just decided to link them together. So right, DEX would then just redirect to Keycloak, and if needed, in certain environments, you can obviously then link Keycloak with your other identity providers like Active Directory, GitHub, or whatnot. Okay, so what's next? So next thing we had to figure out, because eventually things would start to go belly up. We had to figure out what's happening in the cluster and how to keep track of that. So yeah, we'll talk about monitoring. So yeah, here I assume, right, so Prometheus is more or less the standard nowadays for monitoring, and Grafana is very commonly used as a front end. So we just took those things and went with it. But obviously, so if you want to monitor what's happening with your cluster, with the cluster itself, there's this Kubeprometheus stack which we're using, and it comes with everything pre-configured, including dashboards, metrics, API support, and whatnot. So we're using that. We just rip out Grafana because we deploy it separately. And then we have a second Prometheus, which is actually for application monitoring, including model metrics and whatnot. And as mentioned, we have a separate Grafana. So this is kind of what the setup looks like, right? So 2 Prometheus, 1 Grafana. Next thing is logging, right? So we also had to take care of logging. Obviously, it's very important. And you're also having end users to use the logging, right? Because when you submit jobs on Kubeflow, right, so pods are around, just for the duration of the job plus some, grace period, but then they're gone, so you can't, look at those logs there. You actually have to actively collect them. Yeah, to do this, we're using Loki. So yeah, this is derived from this PLG Helm chart, again without Grafana, but the rest we deploy. So then in the end, the whole monitoring logging stack looks like this. Right? So we have Grafana as the central point where users can look into, and then as data sources we have Loki, we have 2 Prometheuses, and obviously Grafana can work also with any databases where you might want to persist some stuff. Yeah. Quick few notes about Kubeflow. Right? So Kubeflow is the central pillar of our platform. It's really great. Users love it. So it scales nicely. You can run pipelines. You can run notebooks. All that. It's very convenient. You can also connect to it remotely, submit jobs remotely. So yeah, works very well. It is very flexible. So this is obviously a good point. But sometimes I don't know, might be a bit too flexible, or at least some defaults, at least for us, were not optimal, right? So we had to, enforce some limits, as I mentioned, right? Otherwise, users would just crash the cluster because they would submit too many jobs and consume too many resources. Then we do change actually containers. So it comes with default containers, but some of them are a bit old. So we provide users with our custom containers that actually provide notebooks for them. And some other things, yeah. But like overall, Kubeflow is great. Yeah. Finally, some like random tips and tricks. Debugging, right? So if you're used to programming, you obviously like to have a way of debug your code, and with Kubernetes, so at least initially it was not obvious to us how to do that, but at least like initial steps, what you can look into logs, you control logs, you can log into your pod, right, and poke around there, right, with kube control exec, and there are also like other nice tools which you can use to poke around, so like K9S, Lens, and others. We strongly recommend using YAML validator for your ID, so it's gonna save you some pain. That's also something that was not obvious for us initially. Yeah, so we're using JQ and YQ as YAML and JSON processors, so also very useful tools. And yeah, so do check hardware requirements of the software you want to run, because well, I mentioned we had some problems with Milestore refusing to run or crashing on suboptimal hardware. So that's important, and also we had some cases where we deployed some incompatible versions of software. So that's also something that you actually have to actively track. Yeah, final two things. So we're using shell operator because it's nice. It's very straightforward to do minor changes on the fly, and we also do testing. Right? So we implemented some of our tests using BATS. So this is Bash automated testing system, which is also very convenient and nice to use. Right, and final one. So this is where we got some gray hair or whatnot, lost some hair, is well, very early on we stumbled onto Postgres crashing, right? And yeah, then obviously like after a while we realized it needs huge pages, but also like how do you do that, right? It was not obvious for us, but yeah, so now we know, easily solved. But yeah, initially you might just run into some things that are just not obvious ones when you're starting. Okay, summary. So key takeaways is automate as much as possible, including testing. Don't be afraid to ask for help. So I didn't mention, but most of those projects that I mentioned, so they have either Slack workspaces or channels or whatnot. Just join them. There's plenty of people there willing to help. Nowadays, also us, right? So especially on Kubeflow, we try to contribute there. And yeah, so also you have to find the right mix between experimentation and learning the basics, right? So you shouldn't really start just by reading up without trying, right? So you have to find the right mix, and eventually with persistence, I guess you'll get there, right? So bottom line, yeah, it was hard, but we also learned a lot. And it's doable, right? Also with small team, right? So we have now this really nice platform. It took us roughly 6 months to get it to a usable state, but now we have plenty of users that are using it. So yeah, go for it. And with this, yeah, I'm open for questions.
Cool. Thanks, Samo, please. We do have a few questions, but I'll ask my question. You say small team. How big's the team?
Right. So when it comes to developing the platform, so let's say 5 people, but not like full time, all of them.
Okay.
Right?
Cool.
Yeah.
Cool. So the first question was, why no public cloud? Was there a threat model done? Is the telemetry encrypted over the air or space? Probably as well.
Right. So good question. So I don't know exactly how that telemetry gets from International Space Station down to ground stations. Exactly. So I know that there is some encryption in there. There's also some custom compression because at least back in the day, so ISS Columbus went up in 2008. The bandwidth was quite a bit lower compared to what is nowadays, right? Yeah, so why no public cloud? So here our hands are kind of tight, right? So because this is kind of a requirement that's imposed on us by European Space Agency, right? So yeah, we can't do. And I don't know about threat model. Yeah, no idea how they came to that conclusion.
It's one of those requirements which was given to you and you have to accept. And
yes,
there you go.
Yes, yeah, exactly.
Fair enough.
Yeah.
What solution do you use for TLS certification management?
Right. So really nothing custom, right? So we're using like Ansible to deploy stuff. And also when we do self-signing, so Ansible has like a module, or how it's called, yeah, to like manage and sign certificates. So that's what we're using.
So you're using self-signed certificates?
Most of the time, yes.
So nothing like, because I'm assuming this is implying for Cert Manager. You can deploy Cert Manager, which will then give you a TLS certificate from Let's Encrypt for free and automated.
No, so we're using self-signed certificates. Yeah.
Do you open it? So because you're using self-signed, are you opening it to the world?
No.
Okay, so it's all internal.
So the deployments, yes, right. So deployments run on some like internal networks, right? Yeah.
Oh, okay, so it's all internal.
Yes.
It's not really, you cannot access it from here, for example.
No.
Okay.
Well, I could through VPN.
Yes.
Yeah.
Okay.
Yeah.
Okay. Can you tell us about the data that was processed by the ML algorithms and what was the learning goal?
Right.
I don't know what you can and cannot say.
So it's sensor data, and yeah, so it's time series, and we are mostly looking for anomalies, and the main problem here is that those devices are so reliable that anomalies are extremely rare, right? So we have certain sensors that see maybe anomaly every 2 years, right? So otherwise you just and the algos that we are developing is to detect anomalies in an automated fashion. Yeah.
Cool. Yeah.
Yeah. That's it. Yeah.
Did you use Istio as ingress or as a service mesh or both?
Right. So we're using Istio like ingress gateway, and that's exposed on node port. So that's one part, but yeah, so we're also using it as service mesh, yeah. So
mainly as a service mesh, and then you're using Nginx as your ingress.
Well, for the actual ingress on the host part, it's Nginx, yes.
Yeah.
Yes.
Why not using Ceph for storage?
Right, good question. We also evaluated it. But yes, somehow, well, pragmatically, right, was a bit easier to go with OpenEBS ecosystem. Also, at least like the claimed performance is a bit better, but obviously then you have the downside that it's a bit more tough on your hardware requirements. So yeah, but like Ceph is like it's a valid solution.
Yeah, I think there's always going to be a discussion of why not one or the other. And finally, you created a self-contained specialized Kubernetes distribution around Kubeflow. Will you open source your configuration setup, Ansible YAML files?
Right. So we're looking into that, but yeah, there's some
needs to go through legal.
Yes, exactly. So
lawyers need to get involved.
There's some steps involved. Yes. Yeah.
I can imagine.
Yeah.
Cool. That was the last question.
Okay.
Unless anybody has any more questions. If not, round of applause for Samo.
Thank you very much.